Two-step equation, modelling multiplication. We are going to be looking at modelling and solving equations that require two steps. Modelling an equation with bar models can help you to solve the equation and improve your understanding of how to solve equations. The equations that we will encounter in this nugget look like this, or like this. Let's take a look at how we can model both of these equations. Starting with 4b plus 12 equals 56. We'll take each term individually and model them. The first term we have here is 4b. We're going to find the value of b. But we have 4b here, so we must draw 4 bars of equal length, and each one has a length of b. Altogether, their length is 4b. The next term to add is 12, so we must draw a bar which has a length of 12. Because we're adding 4b and 12, the 12 will go onto the same row as 4b. This entire length is 4b add 12. One thing to remember, we're not drawing these bar lengths accurately. We're just using them to represent the equation, and this will help us to figure out the unknown value. The last term in the equation is 56. We can see from the equation that 56 is equal to 4b plus 12. So that means that it's the same length as 4b plus 12. So we represent 56 as a bar that is exactly the same length as 4b plus 12. This is our equation fully modelled. We'll look at solving equations a little later in the video. We won't solve this one. Now let's look at modelling this equation. 6m subtract 37 equals 26. The first thing we have in the equation is 6m. So let's draw 6 bars of equal length and label their length as m. Their length altogether is 6m. Now we must subtract 37 from 6m. To represent a subtraction, the 37 will not go on the same row. Otherwise, that is adding to the length. Instead, we'll draw the bar underneath 6m. This shows that we are subtracting the two. The difference, that's the amount left over after the subtraction, is this distance here. We can see from the equation that the difference between 6m and 37 is 26. Because 6m subtract 37 equals 26. So this length here is 26. We've now modelled the equation. It shows 6m subtract 37 is equal to 26. We'll now move on to solving some equations. Solve the equation 8k add 13 equals 85. Pause the video and see if you can model this equation. You might want to try solving it as well. So let's go through modelling and solving the equation. We have 8k, so draw 8 bars of equal length and label them as having a length of k. We must then add 13 to this. So we model this by putting a bar with length 13 next to the 8 bars of length k. So now we have a row that has a length of 8k plus 13. We know that this is equal to 85, so we draw a bar underneath that's the same length as 8k plus 13. And this bar has a length of 85. Well done if you drew a bar model that looks like this. And now we can try and solve the equation using the bar model. We're trying to find the value of just one bar of length k. We can start doing that by finding out what this length is. This length is the same as doing 85 subtract 13. If we were to cut the 13 off, it would leave us with this length. So we must subtract 13 from 85 to get the value of 8k. We can write this algebraically too. 8k is equal to 85 subtract 13. If we calculate this, 8k is equal to 72. And we would write it like this. Now we can find the value of k. We know that 8 lots of k makes 72. So if we divide 72 by 8, it will give us the value of k. We write this algebraically as k equals 72 divided by 8. 72 divided by 8 is 9. So k equals 9. Well done if you managed to find the value of k, which is 9. Here's one last question for us to model and then solve. Solve the equation 3p subtract 27 equals 21. Pause the video if you want to have a go at modelling and then solving the equation on your own. Now let's go through it together. We have 3p, so we draw 3 equal bars of length p. We must then subtract 27 from 3p. So we draw a bar of length 27 underneath. We can see from the equation that 3p subtract 27 is 21. So this distance here, the difference between 3p and 27, is 21. Well done if you drew a model like this. Now we've modelled the equation, let's solve it. We must start by finding the value of 3p. We can see from the bar model that 3p is the same length as both of these two bars. So we must add 27 and 21. We can write this algebraically as 3p equals 21 plus 27. We get that 3p is equal to 48. Now we know the value of 3p, we just need to divide 48 by 3 to get the value of p. We write this algebraically as p equals 48 divided by 3. 48 divided by 3 is 16, so p equals 16. Well done if you got the value of p, which is 16.